All right, so we are going to look at solving logarithms and exponentials. So before we start that, we're going to do a little review of negative exponents. Okay, so if I have 2 to the first, that's 2. 2 squared is 4. 2 to the third is 8. And then 2 to the fourth is 16. So do you agree that as I'm going up, I'm multiplying by 2 every time, which makes sense because it's 2 to the power of something. So if I go backwards, instead of multiplying by 2, I'm dividing by 2. So you have 16 divided by 2 is 8, divided by 2 is 4, divided by 2 is 2. So now if I keep going, 2 divided by 2 is 1. That is why anything to the power of 0 is 1. And then if I keep going, 1 divided by 2 is 1/2. And if I keep going one more, 1/2 divided by 2 is 1/4. So if you notice, we have, okay, so I'm just going to pick out these two and these two to look at. So 2 squared equals 4, but 2 to the negative second equals 1/4. 2 to the first was 2. 2 to the negative 1 is 1/2. So if you have a negative exponent, all it's saying is that you're still going to square this number, but now it's the reciprocal of that. So reciprocal just means you're taking this number, which is technically 4 over 1, and you're flipping it upside down to give you 1/4. So just a couple quick examples. So if I have 3 to the negative 2, instead of having a negative exponent, if I want a positive exponent, I just take 1 over that, so you get 3 squared, or 1 over 3 squared, which is 1 over 9. Here, you would just write 1 over 5 to the third, which is 1 over 125. And then here you would write 1 over 4 squared. Oh, just kidding. My example I made was harder than I was expecting it to be, or than I meant it to be, but that's okay. So if you have a negative exponent in the bottom, so again, you do the same thing, you do the reciprocal. So I take this fraction and I flip it, so you end up, and then you make the exponent positive. So 4 squared over 1, which is just 16. Okay, so let's look at actually solving some exponentials. Okay, so to solve this, again, you're just thinking 10 to the power of what gives you 100. Well, 10 to the first is 10, so 10 squared equals 100. So this would be x equals 2. X time, or 10 to the what gives you 10,000. Well, let's see. X squared is 100, so x cubed is 1,000. X to the fourth is 10,000. So you have x equals 4. And here, if I take this times 10, I just will get x, or I will get 100,000. So this is going to be x equals 5. So you should see a pattern. If you just count the number of zeros, it is the same as what x will be. So if you had 10 to the 100, you would have 100 zeros. So the easy way to do this without a calculator is just count your zeros. Here, we have 10 to the x equals 0.01. Well, this is actually 1/100th. So I like to write them like this instead as a fraction. Okay, so based on our negative exponents, if it's a fraction, we know it's going to be negative. And then based on what we just did up here, you count your zeros, which is 2. So this is going to be the same as 10 to the negative 2 equals 0.01. So x equals negative 2. Okay, this one is 10 to the x equals, this is 1/10, so 1 over 10. So this is the same as 10 to the negative 1. So you're going to have x equals negative 1. This is the same as 1 over, so this is 10th, 100th, 1,000th, so 10,000th. And there's 4 zeros, so that would be, oops, x equals -4. So another way, if you don't want to write it as a fraction, well, -4, you're moving, so this, if this were to start at 1, you're moving your decimal 1, 2, 3, 4 places. Here, if you start at 1, you're moving your decimal 1 place. And here, if you started at 1, you're moving your decimal place 2 places. I think that's more confusing, and I like to write them as fractions, but you can do it whichever way your mind works. Okay, so those were solving some exponents. Now we're going to get into solving some logs. So this, when you're looking at this, you should be like, I have no idea how to solve for that x. But if you put it into exponential form, so remember, this is your base, so you have 10. This is your exponent, so you have 10 to the 5th equals x. And now you can easily write, we just talked about it. So if you have to the 5th, that's going to be 5, 0. So 2, 3, 4, 5, put in your comma. So that would be 100,000. Okay, so then we have log base 10 of x equals -4. So that would be 10 to the -4 equals x. And then, so based on our examples up here again, negative means we're going to turn it into a fraction. So 1 over 10 to the 4th. And if you have to the 4th, that's going to be 10 0, or 4 zeros, sorry. So to the 4th means 4 zeros. So that would be 1 over 10,000. Okay, and then here we just have log of x equals 0. So there's a couple things that are tricky. One, there's no base. So from our last video, you know that's going to be log base 10. So we have 10 to the power of 0 equals x. And if you go way back up here, anything to the power of 0 is always 1. So 10 to the power of 0, you're going to have x equals 1. Okay, so since you are at home right now, I cannot assume that all of you have calculators, which is fine. So instead of putting anything into a calculator, we're just going to get our answers in calculator ready form, and I will explain what that means in a second. Okay, so this one says 10 to the what gives you 125. Okay, so on the last page, we had 10 to the x equals 100 or 1,000 or 100,000. We don't know 10 to the anything equals 125. It's going to be some decimal. So to figure these ones out, you have to put it into log form. So you're going to have log, okay, this is your base, so 10 of 125 equals x. So we have x solved for because it is by itself on one side. And this is what you would put into your calculator. So this right here, this is calculator ready form. This is a perfectly fine answer. Okay, so then we have log base 10 of 500 equals x. Again, we don't know 10 to the power of what is 500. It's going to be some decimal, which we don't know. So this right here is calculator ready form because you can type in log base 10 of 500. Okay, so now we have log base, so here's a 10, of x equals 4.5. So this is saying 10, which is your base, to the power of 4.5 equals x. So this you can type into your calculator. We have x by itself. This is a great answer. Over here we have 10 to the power of negative 10.6 equals x. So same thing. You can type 10 to the power of negative 10.6 into your calculator. We have x by itself, so that is also a good answer. So these are all in calculator ready form because I can just pick up the calculator and type them in. You don't actually have to do that. I actually prefer if you don't for now. Okay, so let's get into a few that are a little more challenging. So now we have, oh, that's hard to see, 10 to the 3x equals 40. So We definitely don't know what this is off the top of our head, so we need to write it into log form. So we have log. Let me back up for a minute. Anytime you're solving for an exponent, so up here you're solving for an exponent, solving for an exponent. If you're solving for an exponent, you want to put it into log form. Okay, so here you're solving for or part of an exponent. So we have log base 10 of 40 equals 3x. Okay, so this one is not in calculator ready form because we don't have x by itself. Up here, as soon as we switched it into exponential, or excuse me, as soon as we turned it into log form, we had x by itself. But on this one, you have this 3 with your x. So to solve for x, this says 3 times x, so you're actually going to divide by 3 on both sides, and you end up with x equals, so these 3's cross out, and you're left with log base 10 of 40 divided by 3. And that is an answer written in calculator ready form because you have x by itself and this you can type in. All right, this one, okay, you're solving for an exponent, so we're going to put it in log form. So we have log base 10 of 30 equals x minus 5. So we don't know 10 to the power of what gives you 30. Okay, we don't know that, so we can't even simplify this side. And then we have x minus 5. So we need to get rid of this minus 5. So we're going to add 5 to both sides. So my next answer is going to be a common mistake. Okay, this and this are not the same thing. You have to rewrite this as, so 10, or log base 10 of 30. So this is one number. So you can't just add a number to this 30 and think it's the same. So you're going to take this and then add 5 to that. So the correct way, you have to put parentheses around this. So this is one number, so you have to put parentheses around it and then add 5. So if you were to type it into your calculator, you would put log base 10 of 30. You would either hit enter and then plus 5 or put parentheses around this and then add 5. And we have x solved for, so this is a good answer. Okay, a few more. This one, so if you notice, this is going to be different from, let's see, this first problem because this has a 3 out front. So before you can put something in log form, you have to make sure that you have just a base. That's so hard to see, sorry. You have just a base and just an exponent. So this says 3 times all of this. So to get rid of the 3, you have to divide. So if I divide both sides by 3, these 3's will cancel out. 18 divided by 3 is 6. So we have 10 to the power of x minus 1 equals 6. Okay, so now we have a base and an exponent on one side. So we can write it, and we're solving for an exponent, so we can write it in log form. So we have log base 10 of 6 equals x minus 1. Okay, so x is not by itself, so we need to add 1 to both sides. And then don't forget, we have to put this in parentheses, so log base 10 of 6, and then plus 1 equals x. All right, this one, it's got this 5 out front and it has the plus 1. So we need to get this base and this exponent by itself before we can write in log form. So the first thing I'm going to do is I'm going to subtract 1 from both sides. So we have 5 and then 10 to the 3x equals 11. Divide both sides by 5. So we have 10 to the 3x equals 11 over 5. Do not let a fraction scare you. This is a perfectly fine answer. So now we have a base and an exponent. So we can write it in log form. So log base 10 of 11 over 5 equals 3x. And then we're solving for x, so you need to divide by 3 on both sides. That's not there for a sec. So divide by 3 divided by 3. So our final answer is going to be log base 10 of 11 over 5 divided by 3 equals x. And that is an answer that you can type into your calculator. You have x by itself. Okay, the last part of solving that we're going to look at is solving with the same base. These ones are my personal favorites. So if you have 10 to the power of something and 10 to the power of something, and they're equal to each other, that means that these exponents have to be the same. So if I have 10 to the third equals 10 to the something, well, this has to be 3. Otherwise, they're not going to be equal. So that means that this exponent has to be the same as this. And instead of saying the same as, you can say equal to. So this exponent has to be equal to this. So let's write that. So you have 3 equals x plus 1. Okay, and we're solving for x, so you subtract 1 from both sides, and you get x equals 2. Okay, this one, we have 10 to the 2x equals 10 to the 8th. So we have the same base, 10 and 10, and they're equal to each other, so that means that these exponents have to be the same, or they have to be equal. So you have 2x equals 8, divide both sides by 2, and you get x equals 4. Okay, this one, we have 10 to the x plus 12 equals 10 to the 5x. So again, same base. So that means the exponents have to be equal. So you have x plus 12 equals 5x. So we want to get all of our x's on the same side. So we're going to subtract x. So we have 12 equals 5x minus x is 4x. And then divide both sides by 4. And you get x equals 3. All right, and our last problem, it's kind of combining two things that we've done. So this one, the x or the base and the exponent aren't by themselves. So we have to get rid of this 13 first. So we're going to divide both sides by 13. So you get 10 to the 2x minus 1 equals 10. And then the first thing you should notice about this is that these have the same base. So we know that the exponents have to be the same. So if you just have 10, what exponent is right here? It's a 1. So we are going to have 2x minus 1 equals 1. We're going to add 1 to both sides. I get 2x equals 2. Divide both sides by 2, and you get x equals 1.